Hello and welcome to the Sub1 YouTube channel. My name is Ray and in this video we're doing an unboxing. Now, late last year I purchased this FNIRSI DDS 350p multifunction oscilloscope. This has a built-in signal generator and also does spectrum analysis. I did do a firmware update on it and it actually improved the range on the spectrum analyzer and removed a couple of little minor bugs. Just after I purchased this one, FNIRSI released a new one, and this is what they've released. This is a 3-in-1 2-channel 100 meg oscilloscope. So this one's a 350 meg oscilloscope. It was more expensive. It is the bigger brother, so to speak. But this has its own features that are pretty good as well. So let's have a look at it. So in the box, let's open it up and see what we've got. All right, so we have a box here. And this one's the accessory kit. It has a user manual, data cable, BNC to alligator clip, like this one had. Set of test pens. So this is actually the leads for a multimeter. And a set of P6100. So these are 100 meg rated oscilloscope probes. So we'll open that up shortly. In the box, everything out of the box. Some packing. And wrapped in plastic we have the scope. So just move that plastic out of the way. So let's have a look. On the front we have two channels plus the signal generator output. We have a vertical scale knob, nice indents on it, and it acts as a button as well. We have horizontal, so this will be for scale adjustment. We have a button up here labeled intensity, and my understanding is it will also do the DC offset for your signals, as well as operate the measurement lines when you're using the measurement feature. We've got cursor, display, measurement and save buttons. Then we've got channel 1, channel 2, DDS, that's direct digital synthesis, that's your signal generator. Maths, 50%, which sets everything to the middle of the screen. Trigger, run. In this spot here, there is an indicator for charging. And down the bottom here is a run button, or a menu button, sorry, and another function button. Let's just pull that off. And we've got a cover over the screen. Right, on the top side, we've got a single button, which is used for single shot capture. We've got an auto button for auto run on the trigger. And we've got 4 input connections for multimeter leads. So we have our common. On the right hand side we have the input for volts, ohms, capacitance, diode and continuity, which is the most common used on nearly every multimeter. Then we have milliamp and amps for measuring current. So it's full multimeter functions there. On this side, hard to see, there is a little hole here, and that is a master reset in case something locks up. On the other side, we have the power button. On the bottom, there's not a lot there, just the feet. And on the back, we have a USB-C port. This is for both data and for charging. there's another screen cover on this front. And we also have a fan here for cooling. And we also have these two legs which kick out as a stand. And it's not a bad angle for when you're working, but for the purposes of this video, I'm just going to leave that closed up so it's easier for people to see. I'll just move that light a little bit so it doesn't shine in the screen. All right, let's have a look at our accessories. Okay, we have another empty box. Right, so here we have the manual. It's both Chinese and English. So here at page 30, we start with our English. So the first half of the book's all Chinese, which makes sense since it was manufactured by a Chinese company in China. And the instructions aren't bad. They do cover most of it. The only thing that was a bit disappointing is there was no mention of the power charge light. Now, what I have since learnt is while it's charging, that will glow red, and once it's fully charged, it will glow green. And I haven't found that in the manuals anywhere. We've got a set of multimeter leads. They call them probe pens, I think it was. Yeah, look, they're not the best leads in the world. I have had better leads come with other meters. It's not the worst I've ever had, but it's not that nice silicon feel to it. So it's 20 AWG rated at 2000 volts, 80 degrees C. They are category 3, I think they are. Double insulated. The tips come off. So while the tip covers are on, they're category 3, rated to 1000 volts. Category 4 at 600 volts. With the covers off, category 2 at 1000 volts. And they've got little covers in here to keep the dust out. We have a USB lead. So this will be a USB lead A to C and supports data over the lead. When looking at USB leads, remember there are a lot of USB leads that are A to C that do not support data. They are used purely for charging. This one supports data. Okay, so this one is a BNC to a pair of alligator clips. I've actually got quite a few of these ones now, building a real collection of them. One of these came with my DPOS 350p because of the signal generator component. This one has a signal generator, so I believe that's what this one's come for. Testing I have done, oh, there's a little QC tape, bit of paper. Now in this little bag, we've got information on the probes. So this is the P6100, so the 100 meg probes. We get 2 of them in the pack, These are a 1 by or 10 by impedance, and they've got a little adjustment on here. Inside another plastic bag, they've got a few rings, a grounding clip to go on when you pull the hook type off. You can put the grounding spring on there. They come with ground leads that clip on down the back. Little screwdriver to adjust these little trim pots, and little rings that you can put on both ends to help identify which one's plugged into which port. Another YouTuber did make mention that they don't supply a yellow one, and I didn't get a yellow one in this kit either. Interestingly enough, a lot of the older scopes used to always have, or probes used to have, the yellow one in them. The two yellow bits go on the end. One covers up the shield on your probe if you're using without the hook. The other one will also cover up that shield and protects the pin a little bit, makes it easier for putting onto pins of components without shorting to the pins beside it. Alright, so that's what we got in the bags. Let's turn it on and see what we get. Now there are already firmware updates for this. I haven't applied any firmware updates to this because I've just pulled it out of the box. So let's get one of these probes and plug it in. Start with channel 1. This screen is a touch screen. So we've got our multimeter functions there, and they show, the multimeter shows up down here in this corner. I clip this onto this point here. That's our reference signal. And if I hit channel 1, and I thought there was an auto. All right, so the auto button does configure the automatic setting. And we can see by the waveform that this does need to be adjusted. That looks better. Now let's hook up our second channel. That's interesting, I didn't turn that on yet. But I do need to calibrate it as well, so channel 2's lit up. So vertical, I can change. In theory, these two should be identical. That's a bit better. So this is an offset adjustment. And we've got our vertical height. At the moment, I'm only affecting channel 2. If I push this button, channel 1 is now selected, and I can make the same change to it. 50% should set our voltage in the middle. Trigger to channel 1, set it for... Alright, so it's set for rising edge. That's better. Adjust our trigger level up. Alright, so if you click on this, you can either adjust the trigger level. Clicking on it will let you adjust when it triggers on your display. So it's triggering earlier in the display. Pressing this switches between channel 1 and channel 2. At the moment we're outputting a square wave from our digital frequency signal generator, and we can change that. So that's our triangle. They've called it a ramp. You can change the frequency and the amplitude. I believe 3 volts is as high as it will go. Yeah, 3 volts is as high as it will go. DC, noisy, oh, there's a sign over there. Half wave, full wave, stare positive and stare negative for our signal generation. So let's leave it on that stare negative for a sec. That signal's coming out here. That's a fixed 1 kilohertz. No, that's a 100 kilohertz signal. So I do have a lead that will connect our frequency generator and connect it to one of our inputs. I'm just going to disconnect that. I think I just bumped the auto. And channel 2, I'm going to turn off. All right, so what we're seeing here is a frequency of saying 100. %50 duty cycle. So that's supposed to be a 1 kilohertz. Frequency, duty, period, I think that is. And we'll take voltage peak to peak and RMS. So I've got my first bug, so I think I'm going to have to do a firmware update on this. It's saying frequency 100 kilohertz, yet the output is 1 kilohertz. Go figure. Yeah, not telling me anything I really want to know there. All right, let's have a look and compare that on the other scope. So I'll just turn this one on, just to verify what it's telling us. So this one is showing 1.002 kilohertz, which is what we're expecting. RMS voltage is saying 14.5 volts. Hang on a minute, I know what'll be going on here. All right, 1.45 volts, that sounds more like it. RMS. Peak to peak is 2.2 by 3 volts. And the period is saying 99.84 microseconds. So their value is very close to what I'm expecting to see. And I'm looking at a duty time of around 49.99%. So it's what I was expecting to see with this. So if we go back into our signal generator, change it to sine, amplitude 3 volt, that'll be peak to peak. I'm still only seeing 2.87 coming out of it. So we might have to do the firmware update. I know there were 2 firmwares for this, and we'll give it a try. In the meantime, let's try reversing the roles. I'm going to plug this into channel 1 and plug this one into the signal generator. So our signal generator currently, I'm just going to auto configure this one. Well, that's interesting. So let's change our type. Sine wave, triangle, sawtooth, sawtooth the other way, step, half wave, full wave, exponent, ringing. Now if I adjust that trigger up a little bit, we can get that to stabilize. Square root. Multi-sine. Sin C. DC. This is 5 kilohertz. And capture. So this one will need to be reconfigured. So that's an interesting output. I'm not completely convinced that's faithful. I will have to try that against another scope. So I think we definitely need to do the firmware update. This is a much more powerful oscilloscope than this one. So it's trying to tell me that the frequency is 9 megahertz, and I can understand why it might be trying to tell me that. Let me just... The problem with this particular signal was actually captured using a clamp on this oscilloscope, and the VSD that was drawing that current has since blown up. It was a preliminary warning that it was about to fail by the looks of it. I do plan to capture that one as we're about to recommission that machines at work, so I might try and capture with both of these. This one will let you save, but it'll only save a bitmap. This one will do a screenshot, which saves as a bitmap, but it'll also save the wave so you can go back and do measurements on it later. All right, let's try some basic voltage. So for that, push on that and get the multimeter probes out. I think it picked up I plugged something in there because it beeped at me. All right, let's see what we get. I've got a bench power supply. It's reading 4.9 at the moment on it. That's pretty accurate. Turning it down a little. Saying 3.4 now on the bench power supply, and I'm getting 3.99 volts on it. I do have another gizmo. Okay, so a little while back, I got this reference voltage calibration tool. It runs on USB-C, so let me get a USB-C lead. Now, it's programmed for 2.5 volts. According to a voltage calibration that goes to 1, 2, 3, 4, 5 decimal places, we should get 2.498. .494. Sorry, should be 2.496. That's not too bad. It's actually pretty good. That's only 2 divisions away. Well, let's change the voltage. I'll go for my 5 volt setting. And that's in auto. So 4.98485. I should be getting 4.9901. So that's not too bad. I'm just going to put this into volts DC. If I click on that again, it goes to AC. 3 ohms. I've got some resistors on here, so let's see what ohms gives us. So on 10R, I should be getting 9.9845. So we've got a little bit of an error there. This one's the 100R. I should be getting 99.983. 1K should be reading 1.00007. NK should be reading 10.0015. And 100K should be reading 100.099. So it's within a bull's raw. It's not the most accurate I've ever seen. Go back into DCs. 4.985 should be 4.9901. I'll switch to 10 volts. Right, so it should be giving me 9.9867. 9.976. That's not too far off, but it's still not spot on. It's good enough for most work. So this one should be 1.24264. So it's consistently accurate to 2 decimal places and starts to drift off to after the third. It's not too bad. I've seen worse. Seen much worse. All right, so putting that back onto our DC power supply. And why am I getting a reading there? There we go. Just crank the voltage up a little bit. So I'm showing 8.9, which is pretty good. When we set this back to our oscilloscope reading, you can see the multimeter range is down here. And I don't know if you can see that on the screen, but it is reading that 8.901 volts. So as a field tool, I think this is going to be pretty useful. Well, if you like these videos, don't forget to click on like, subscribe, ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have a Patreon account and YouTube membership, and you can join my VIP patrons Go Lucky, Jeff Jerd, and Kuriz Contini, my builder patrons Elmorellis 45, Andrew Cardone, and Egar 69, and my YouTube member Joel Huxwell in helping support the channel. All my YouTube members and patrons get these videos at least a week early. If you've got any questions, feel free to leave your question in the comments below or drop into my Discord and leave your question in there. If I can't answer it, someone else might be able to. And we'll see you in the next video.